So taking another look at a quadratic situation in context, two numbers multiply together to give you 253. So what could that look like? A number like x times y, remember a little invisible times sign there, is equal to 253. So I'm going to kind of try to visually represent what each part of this question tells me. So the first thing I know is if I times two numbers together, I'll get 253. I should say here one, not once. One of the numbers is 12 more than the other. Okay. So if x is equal to x, we might say that y is equal to x plus 12, because it's 12 more than the other number. So now that I know that, I can think about doing what we call substitution. If I know that y is equal to x plus 12, let's replace y with x plus 12. So we'll keep our brackets here, because we want to say x times everything that y is, which is, in this case, x plus 12, is equal to 253. So I'm taking this number and I'm substituting it in, and it's not a number, but I'm taking that expression that we know that y is 12 more than x. So instead of writing y, I'm going to write x plus 12. And we've got that invisible times sign there. You might choose to leave that out and just have the x bracket x plus 12. But again, here we need to make sure, first thing, that we set equal to 0, and second, that we factor before we solve. So here I notice it's not equal to 0, so I need to do what? I need to expand it out first. So that's going to become x squared plus 12 is equal to 253. Need to set it equal to 0, so minus 253 from both sides. So I get, oops, that should be 12x. My bad, x times 12. So x squared plus 12x minus 253 is equal to 0. So now I need to factor it, which is potentially a pain here because this looks like a big scary number. But I need to think about what times this to 253. And you can pull out a calculator and start timesing things up or thinking about what it might be. You could also think about doing a prime factor tree, it can be quite helpful. But I'm recognizing a trick in here, which is that this is a 3-digit number, and the first and last digits add together to give the middle digit. So 2 plus 3 gives me 5. So I know that 23 times 11 will get me 253. So that's one of my options for factors, and if I double check this, can I get it to add to 12? Yes, in fact, the difference between 23 and 11 is equal to 12. So I can get timesing to 253 and subtracting there to get me a positive 12. So because this is a negative at the back, I know I need at least one of those to be negative. And I'm going to say it's going to be the negative 11, because if I do positive 23 minus 11, I'll get positive 12, which is what I need in the middle. So x, and we're going to go positive 23, x minus 11 equals 0. So setting both of these equal to 0, or x minus 11 equals 0, we're going to get x is equal to negative 23, or positive 11. Now, again, it's quite easy to think, oh, I've solved the problem because you've got to the end of the quadratic equation, but remember, this is in context, so we've got to go back to what are they actually asking us. What are two numbers, right? So find the two numbers that are possible that can times to 253 and add, and that one of them is 12 bigger than the other. So I've been given two answers here, and I need to think about what that means. Is it possible to have a negative number? Yeah, this is not like the negative length on a rectangle, which makes no sense, but here if I'm just talking about numbers, I can have a positive or a negative, so both of these will work. So I need to think about what are my possible pairs of numbers, because x is just the first number, and we have to remember that y was 12 more than x. So my possible solutions could be x is equal to negative 23, and y is equal to negative 23 plus 12. Which would give you negative 11. So that's one combination. Or, because I know I've got two answers here for x, my other x could be 11, and my y then would be 11 plus 12, which would give you positive 23. So we've got two possible combinations here, negative 23 and negative 11, or 11 and 23. So in both situations, there's a difference between them of 12, and if you times them together, you get positive 253. So both of these will work as our solution, so we would give them both as a solution in this case.